So, hey everyone, my name is Jordan. I'm a developer at Stratis, and today I'm going to be showing you how very soon you'll be able to start deploying smart contracts in C# on our new platform. I'll take you through a few main areas. Firstly, what are smart contracts and why are they important? Then why did Stratis need to go and create a new platform, and how is it different from existing platforms? And finally, I'll give you some insight into how it looks and feels to start developing smart contracts with us. If you have any questions, please hang on to them till the end, and I'll definitely make some time. So I thought it would be good to give a bit of an introduction to myself and how we got here. So I have long been a .NET developer, and for me, this meant building big back-end websites for kind of governments back in Australia. I realized as a .NET developer that we're extremely spoiled. We essentially have one tool, Visual Studio, that allows us to debug, test, and deploy all of our code. On top of that, we get to use a really beautiful language, C#, and we have a really amazing developer community. And with this, of course, comes amazing documentation and best practices for pretty much everything. So I came from this amazing ecosystem, and early last year started building smart contracts on Ethereum. Conversely, with Ethereum, you have to use essentially new everything. So new programming language, Solidity, and all of the tools in the ecosystem really feels really young. I was really frustrated this whole time because I really just wanted to use my favorite tools. I really just wanted to use Visual Studio, and I really just wanted to use C#. So I started taking steps to remedy this. The first thing I did was I started building a C# to Ethereum virtual machine compiler. What this would do is take C# code and ultimately compile it down and start outputting Ethereum virtual machine instructions. My end goal here was to start replacing Solidity. So this process actually worked. It worked really well, but unfortunately there was one big flaw that I could never quite get past. When you compile it down like this, you ultimately, in the end, are running a completely new instruction set on a completely new virtual machine. It doesn't function anything like the way the developer had intended. And with C#, we have developers that have been developing for maybe 10 or 15 years. So it just wasn't fair to start telling people, hey, you can start developing in C#. It wasn't really true. So instead, however, luckily I was very well in touch with the guys at Stratis, and we decided that we would build a smart contracts platform that was .NET from the ground up. So in terms of Stratis then, Stratis basically provides a platform for building applications. Everything is centered on a full node for Bitcoin that is completely written in C#. Our kind of guiding principle is that blockchain development should be easy. The current barrier to entry that exists shouldn't be so high. For us, this means wherever possible using C# and leveraging the .NET ecosystem. We kind of have a range of products that are in the works, out now, and coming out soon. Some of these, obviously smart contracts is one of these, but we also have exciting things like sidechains, masternodes, wallets, and so on. And everything, again, is in C#. So say you're out there and you have a really good idea for a blockchain application. Maybe you have some great idea where you want to leverage transparency, maybe to replace some government entity. Maybe you have a really good idea for some kind of corporate application where you can really leverage decentralization, remove some middleman, and everyone can reap more value from the process. So one thing you may be looking to do, for example, is build an auctioning platform. You could build an auctioning platform in a way where any individual can come and start interacting with any other individual. People can buy and sell and list items, and anyone can kind of come and start bidding on these items. So this is a great idea. This would be a great idea because this central entity would have less control over the process. You wouldn't have anyone that's kind of taking 10% of every transaction. And you wouldn't have anyone that could exert too many rules. So this is a great idea. You should go and do it. But if you wanted to do it maybe 3 years ago, before smart contracts were a thing, you had a really difficult situation. This was a really arduous process to go and do this. You would have had to first go and clone an open source blockchain repository. Probably something like the Bitcoin core node. You would then have to go and build into this code your required functionality. This could be new opcodes, new layers to the consensus protocol, whatever it is to get your auctioning platform working. So that's all good, but the hardest part here is absolutely this last part. You would have to somehow convince enough people around the world to start running your node. You would have to convince enough people to start giving their computing resources so that people can start mining and essentially people can start leveraging this decentralized network. Obviously, if the code's just running on your computer at home, it's really not much use. So obviously, there's a big issue with scalability here, and this is where smart contracts come in. So formally defined, smart contracts are snippets of code that extend the functionality of a blockchain, allowing it to map out complex financial interactions through the sending of funds and storage of data. What this means is anyone can come, me for example, I could come, write a bunch of code and deploy it to a chain, and this underlying chain now has more functionality than it did before. For example, I could go and write a bunch of auction-related contracts, deploy this on-chain, and now anyone can start interacting, start bidding, whatever you need for your auctioning environment, all on this one underlying chain. We no longer have to convince people around the world to start running our node. So the guiding thing here is smart contracts really make blockchains general purpose. So just some of the use cases that are kind of really popular at the moment. Obviously, auctioning, we've touched on. Tokens as well. You're very likely aware that most tokens that you're investing or buying now actually exist as subcurrencies on another chain. They don't actually have their own underlying network. Getting into some more complex scenarios, you have things like peer-to-peer lending and peer-to-peer betting. Obviously, in these cases, we're trying to remove some financial middleman, like maybe banks or wagering companies, and everyone can leverage more value from that transaction. Getting down to the really complex end of things, people around the world are looking at things like self-sovereign identity. So this is the idea that individuals manage their own identity. It exists on-chain. There's no kind of maybe passport issuing authority or whatnot, and as the owner of your identity, you can give people access to certain parameters. So that's really getting into kind of the more complex side of things, but this is just touching on some of the things that are possible with smart contracts. So say smart contracts, obviously, we know now are important, but say you're Stratis. Say you actually want to go and build the underlying platform. How do you do this? And this is actually a really interesting problem. If you know much about blockchains, you'll understand that they act by having nodes all around the world continually reach consensus about the state of some data. This could be the transactions that have been made, or this could be, say, the current balances of everyone, or so on. So that's all good, but when you start introducing smart contracts, it's a really tough problem, because what you want to be able to do is let anyone start deploying useful code. Anyone should be able to start deploying code, yet at the same time, whenever this code executes, around the world, all the nodes have to execute the code in exactly the same way and always yield the same result. For example, my 64-bit Windows computer running now maybe needs to execute a contract and yield some result. And at the same time, a node that's syncing 2 years from now needs to run this exact same code. This node could be in China. It could be running a completely different language. It could be running Macintosh. And it could be maybe 32-bit. Yet despite all of these things, the code has to execute and yield exactly the same result. So tough problem. The very first solution to this is to build a custom virtual machine. The most common example of this is the Ethereum virtual machine, which you'll likely have heard of. The idea here is that this virtual machine and its instruction set are inherently constrained. There's no way in the EVM that you can somehow retrieve external information. You can't make HTTP calls. You can't access any information about the underlying operating system or so on. And on top of this, when these virtual machines are created, they natively track resources. And so we'll talk about why this is important in a second, but we really need to be able to track memory consumption, storage consumption, and of course the number of CPU instructions being used as well. So this all works, this kind of Ethereum approach, but it requires a completely new ecosystem. And this comes back to my problem initially when I started writing the compiler. Because of this completely new instruction set, you have to build everything from scratch. New language, Solidity, new development environments. And this is why you see things like decompilers for Ethereum are still in development. They're just not ready for production yet. So at Stratis, we decided to do something different. We've taken a very different approach. We decided that from the beginning, we would use the .NET virtual machine. This is known as the CLR, or the Common Language Runtime. Obviously, we don't control this machine, so we can't kind of constrain it inherently. What we can do, however, is constrain the user code that runs on it. So it's a different approach, and rather than constraining the virtual machine itself, we constrain the code that runs on it. So what happens here is when code is deployed on-chain, nodes will check that this code meets certain criteria and is always deterministic. That means that it will check that the code always yields the same output given the same input. So I'll talk a bit more about how we solve that in a second. We also are able to track resources. Again, obviously, we don't control the virtual machine, so we have to do some extra really cool things to be able to track resources. I'll talk a bit more about that as well, but this enables us to get really accurate metrics of kind of how much storage, memory, and CPU instructions have been used. So there are some really tough problems there, but once we solve them, we actually have a really great outlook. We are able to actually use an entire existing ecosystem. For us, this ecosystem is C#. This ecosystem is Visual Studio. And essentially every tool that developers are already used to, they can start using now. So it means finally I can start writing smart contracts in C#. So some of those tougher problems, just to touch on like how we fix them. So deterministic execution. It's this idea that given the same input, nodes always have to return the same output, no matter where they are in the world, no matter the architecture of the machine, and so on. So what we do is we validate the code that is deployed on chain at the instruction level. So byte by byte, we ensure that certain criteria is met for every contract. So the first, just some of the examples of things that we do, but the first one is we limit the amount of libraries that can be used. So in C#, you can only use system.link, and Stratis.smart contracts. This might not seem like a lot, but it actually provides you with more functionality than Solidity out of the box. You're not allowed to make any network, operating system, or architecture calls. Obviously, these are things that could cause issues with determinism. So what we do is we detect these, again, at the bytecode level. In .NET, these are pretty easily recognized as p-invoke or unmanaged code calls. We don't allow any floating point arithmetic. You can imagine that 32-bit and 64-bit machines react differently when they're calculating floating point numbers. There can be some issues in the last few digits not being exactly the same. To combat this, we just disallow use of floating point numbers. Threading is an obvious one. If you have kind of many threads inside of a smart contract, we have no control over in which order those threads are going to finish. Could be an issue with determinism, so we disallow those. And finally, finalizers. So the garbage collection in .NET is non-deterministic. We don't have any control over when and how it will happen. So to combat this, we just disallow use of finalizers. And finalizers happen anytime an object is cleaned up by the garbage collection. So then resource tracking. So as mentioned, when a contract's executing, if it's executing on my computer, it actually costs me something. It costs some storage on my hard disk, costs some on my memory, and it costs some CPU time as well. So we need to pass this cost onto somewhere. We need to know and have an accurate metric of what this contract is spending. So we refer to this by calling the idea of gas. So gas essentially is a fee that is paid by someone for contract execution. And there's a related problem here, which is checking for infinite loops. You can imagine in our consensus model, if contracts come up against some code that is going to loop infinitely, there's going to be a problem there. The nodes are never going to be able to get past this and never ultimately be able to reach consensus. So to fix all of these things, again, we do something really cool. We break up the code by branching instructions. So at the lowest level, you can imagine that code essentially exists in blocks. Every time you have a new if statement or a new while loop, this is essentially a new block. You'll meet a branching instruction here. So we break up the code by branching instructions into segments. For each of these segments, we count roughly the amount of computation inside and then spend some amount of gas behind the scenes. So to show what this looks like, if you're a developer, you'll recognize that this kind of bid method up the top, it has kind of three sections. There's a part down the top, a part in the middle inside an if statement, and then a part down the bottom. You can imagine on depending what criteria is met, the contract is going to follow a different line of execution. For example, it may go into the if statement or it may not. So that's the code that the developer actually writes. But the code that the node runs behind the scenes is the code like down the bottom. So what's happening here is the node will count roughly the amount of computation in each of these blocks and then append some kind of gas amount that is to be spent before each of these segments is executed. So this gives us really up-to-date metrics on kind of how many instructions are being run at any time and how much memory and storage are being used. And more importantly, it prevents infinite looping. You can imagine if the same block of code is being hit over and over and over, it's going to cost a huge amount of funds. The contract will quickly be terminated and the nodes can all move on and continue to reach consensus. So those are just some of the problems that we had to solve. But in terms of now what we're able to release because of this. The first thing is a proof of work smart contract daemon. So this is going to be a daemon that you will be able to run on your local machine and be able to start joining or creating your own smart contract test networks in C#. A NuGet package, Stratis.smart contracts. So in order to start writing smart contracts, all you have to do is actually include a NuGet package inside of your C# project, and you can instantly start writing smart contracts. A command line validation and compilation tool. So as mentioned, nodes will be validating your code to ensure that it meets certain criteria. You're going to need to do the same when you're developing. So this tool will give you some kind of live feedback on whether your code is deterministic or not. Finally, there will be some documentation as well, and also a smart contract and unit testing Visual Studio template. So this is really cool. I'll show you what this looks like. Imagine you open Visual Studio, hit File, New. Straight away, you will be able to, just like you were creating a console application, just like you were creating a web application, you'll also be able to create a smart contract project. So once that's created, you'll essentially have a brand new solution with 2 projects inside. So you'll have the actual contract project itself, a sample contract that will give you. In this case, it's an auctioning contract. And also a unit testing project as well. So to jump in really quickly to what the code looks like and what a smart contract looks like in C#, you'll notice up the top we've included Stratis.smartcontracts. Then all we had to do was override the smart contract class, and other than that, we're just writing an object in C#. If you're wondering what a smart contract is in terms of C#, it's just a singleton that is created and lives forever, and anyone can come and start calling methods on it. So it's kind of like a vast simplification of what you have to understand rather than having to go and sift through Solidity. So leveraging some of the .NET ecosystem here and really showing some of the power of that, you'll notice we also have a unit testing package inside of this same solution, inside of this same template. So this is really exciting because inside of Visual Studio, you can instantly start writing and debugging unit tests. So rather than having to come up with custom debuggers, you can do all of this inside Visual Studio and debug contracts just as they would be executing on chain. So out of the box, there will be, for example, a bidding and a contract construction unit test. Also, a validation and compilation tool. Again, as mentioned, nodes are going to be validating your contracts. You're going to need to do the same. So we'll provide this unit testing tool. So ideally, in the future, this will all be integrated inside of Visual Studio. But out of the box, this unit testing tool will enable you to validate that your code meets certain criteria. You'll see, for example, down the bottom left, when we try and validate this auctioning contract, it returns determinism valid true. You can imagine that if I do something like retrieve the current date time, this is going to be problematic. It will return a different result on every machine. So in this case, what would happen is it will say, hey, on line 36, you're trying to get the date time. This is non-deterministic. You'll need to fix that. And of course, as well, it will give you some bytecode output. So this is essentially just the .NET code that is sent to the chain. If you wanted to, you can grab this, put it inside of a transaction, send the transaction to the network, and this contract will be created. So deploying then, in the same tool, you can also run the deploy command. So this is really exciting because as long as you have a node running behind the scenes, you can just put this contract in and it will instantly go and deploy it on chain. So we'll go through a series of steps, and you'll notice down the bottom left, it ultimately has deployed the contract to the network and it gives you an address. So this is just a Bitcoin or a Stratis testnet address. But what's really cool is there is now contract code that it permanently lives there. So we have kind of an API behind the scenes that developers will be able to use to start querying and getting information about contracts. And for example, what this looks like is if I go and put the address in, I can instantly get the code running at that address. For example, down the bottom, you'll notice we have the bytecode output. And so that's nothing special. That's just the bytecode you saw a couple of slides ago. But again, where we can leverage the .NET ecosystem is this is actually decompiled on the way out. So this is yielding real C#, the actual source code for every single contract. So this is a leap forward in terms of security. Rather than having to wait for developers to go and validate their source code for every single contract that exists maybe on the Ethereum blockchain, in our case, you can audit every single contract that exists in real C#, the C# that it was written in. So finally, now that the contract exists, we may want to go and call some methods on it. This is actually really simple as well. So you just have to craft this little request. So long as you have the contract address and the method name, you can start calling contracts. So in this case, it's as easy as putting in the contract address and just bid, which will call the bid function on this contract. So ultimately, that's kind of what's going to be deployed for the alpha. We're expecting this to be available within the next 2 months, so sometime Q2 this year. In terms of what we're looking for long term, we're going to have a live proof-of-stake smart contract-enabled sidechain. So this will mean that your tokens that you currently own in Strat will be available to be used in terms of smart contracts as well. We'll also have a Visual Studio integration for inline feedback. So everything that you just saw that was a command line tool will also be available inside of Visual Studio instead. Then stratus.smartcontracts.standards and .tests NuGet packages. So this is really exciting. If you're aware of maybe Ethereum or Neo, you'll know that there are ERC or NEP5 contract standards. In our case, all you have to do to access these is include this NuGet package, override an interface, and you're now good to go, rather than having to try and crawl through GitHub issues. So longer term then, there's like a bunch of really cool things we're looking at doing. One of the most exciting for me is F# support. So again, we're just using .NET. We're just using kind of real C# and .NET. So we'll also be able to natively support F#. And this is really exciting as because F# is functional, it really opens up a lot of opportunities for us with formal verification of smart contracts. That's it from me. And yeah, I'll take some questions now.